Amplitude modulation, AM, is a technique used in electronic communication, most commonly for transmitting information via a radio carrier wave. AM works by varying the strength of the transmitted signal in relation to the information being sent. For example, changes in signal strength may be used to specify the sounds to be reproduced by a loudspeaker, or the light intensity of television pixels. Contrast this with frequency modulation, in which the frequency is varied, and phase modulation, in which the phase is varied. How AM transmitter works. The information or the intelligence to be transmitted starts as sound wave which travels through air. The microphone picks up this wave and transforms them into electrical energy. Now the information traveled into the transmitter taking the form of audio frequency voltages. Audio frequency generally falls within a range from 300 to 3000 cycles. However, it is not practical to transmit these audio frequencies directly. An oscillator provides the much higher frequencies. This radio frequency wave called a carrier, by means of a modulator, and one or more RF amplifier. The amplitude variations of the audio signal and radio frequency carrier are combined. Radio frequency amplifier. An RF amplifier is distinguished by its ability to tune over the desired range of input frequencies. The shunt capacitance, which adversely affects the gain of a resistance capacitance-coupled amplifier, becomes a part of the tuning capacitance in the RF amplifier, thus permitting high gain at radio frequencies. The power gain of an RF amplifier is always limited at high radio frequencies. However, the power amplifier combines the RF carrier and the modulating signal in the power amplifier to produce the amplitude-modulated signal output for transmission. In the absence of a modulating signal, a continuous RF carrier is radiated by the antenna. Now the information takes the form of amplitude variation in the carrier. The amplitude-modulated RF carrier is inserted to the antenna from which it is radiated through space. The amplitude modulation RF carriers is picked up by the receiver antenna, and it will accept the information carried by the RF, then transforms it back to an audio signal, amplifies it, and send it to the speaker. To the receiving antenna, once the signal has left the antenna, however, it can be affected by many disturbances. For example, the thunder will produce a new variation that would cause a disturbance in the original amplitude variation sent from the transmitter, but the distortion does not affect the frequency that is being transmitted.